Hello everyone. Today I am going to discuss two reactions of synthetic importance. They are Schmidt reaction and Oppenauer oxidation. First, start with Schmidt reaction. Introduction. It is named after Carl Friedrich Schmidt, who first reported it in 1924. Scientist Schmidt was first discovered and reported this reaction. That's why it is known as the Schmidt reaction, or it is also known as the Schmidt rearrangement reaction. Right? Scientists successfully converted benzophenone to benzanilide. Right? During experiment, first of all, it tried on benzophenone, and benzophenone was easily converted to benzanilide by the scientist, and that's why it is known as the Schmidt reaction. Right? Schmidt reaction is the organic reaction in which an azide, that is hydrazoic acid HN3, reacts with carbonyl derivative, usually a aldehyde, ketone or carboxylic acid, as well as alcohol and olefins. Right? In short, Schmidt reaction is for the carbonyl compound like aldehyde, ketone or carboxylic acid, and this reaction is carried out with the help of azide, that is hydrazoic acid, and this reaction is catalyzed by the different acid catalysts like sulfuric acid and Lewis acid. It has become important in synthesis of natural products. Say general reaction. First, reaction of acid. Right? Say reaction RCOOH, that is carboxylic acid, undergoes this Schmidt reaction, that is in presence of H plus acid catalyst and hydrazoic acid or azide, that is HN3, as well as in presence of water molecule, and form the corresponding amine molecule, right? RNH2. Color of the atom show the its root, from where it becomes in RNH2 amine. R, that is alkyl group of acid, NH, that is from the azide molecule, and H, hydrogen, one hydrogen is from water molecule, right? That's why when carboxylic acid undergoes Schmidt reaction, it produces the corresponding amine. Right? Reaction of ketone and aldehyde. When aldehyde or ketone undergoes Schmidt reaction, it produces the corresponding amide. Right? Remember the difference. Acid produces amines and aldehyde or ketone produces amide. Now mechanism. Say first a mechanism for acids. When acid undergoes this Schmidt reaction, how it forms the amines. In first step, acid undergoes the protonation. See, in first step, acid undergoes the protonation. Right? Protonation of the oxygen of OH group will occur and form the protonated acid. Now, due to this protonation, oxygen of OH group acquire positive charge. In positively charged, oxygen become unstable and try to regain its electron, right? So that bond between carbon and oxygen will break, and it releases the water molecule, right? Electron of this bond remain on the oxygen atom, so that it release as a neutral water molecule, and carbon acquire the positive charge, as seen in first one structure denoted as 1, right? That is the acyl ion or electrophile, right? And carbocation. Right? Now on this positively charged carbon, nitrogen atom from the azide will attach. Now there are 3 nitrogen atoms in hydrazoic acid or azide molecule, right? Out of them, nitrogen that is directly attached to the hydrogen atom is attached to this positively charged carbon atom and form the structure 2. Right? See in structure 2 what happen? RCO attached to the hydrazoic acid through the nitrogen that is directly attached to the hydrogen atom. Right? In next step, what happen? Rearrangement will occur and it releases the N2, that is nitrogen gas molecule, N2 molecule, and form the isocyanate derivative, that is structure 3 is example of isocyanate. Right? In next step, hydrolysis will occur. Right? Water molecule is added to the isocyanate molecule and produces the intermediate 4. Right? And intermediate 4 is nothing but the carbamic acid derivative. Right? Now, deprotonation of this carbamic acid will occur and form the intermediate 5. Right? Now, carbamate converted into carbamate 5. Now, rearrangement of this carbamate ion will form the amine and loses the carbon dioxide molecule. Right? So, finally it produces the corresponding amine, that is RNH2. Next mechanism for ketones, RCOR-, right? Ketone or aldehyde. Now, again, this mechanism also start with the protonation of the carbonyl oxygen. Right? Protonation of carbonyl oxygen make the oxygen atom positively charged. Why? This protonation occur on oxygen atom so that lone pair of electron is used by this proton to form the bond with it, that is OH bond. Right? So that's why oxygen acquires the positive charge and it becomes unstable and try to regain its lone pair of electron, so that it breaks the pi bond between carbon and oxygen, and bond of this pi bond will remain on oxygen atom and form the neutral OH group, and carbon acquire the positive charge, right, and form the first intermediate. Now, on this positively charged intermediate, azide molecule will attach. Again, this azide molecule attached to this positively charged carbon through nitrogen atom, which directly attached to hydrogen atom, right, and form the intermediate 2. In the next step, what happen? Dehydration, right? How water molecule is released? See in structure 2, intermediate 2, there is OH group on carbon and hydrogen atom on nitrogen atom, right? So from nitrogen atom, H plus is removed, and from carbon atom, OH minus is removed, and H plus OH minus form the water molecule and it is released from the molecule. Now, when H plus leave the molecule, nitrogen acquire the negative charge, and when OH minus leave the carbon, carbon acquire the positive charge. Now, there is a pi bond formation between nitrogen and carbon by using the lone pair of electron on nitrogen, free electron on nitrogen, and form the structure 3, right? Now, again, rearrangement is occur and nitrogen molecule N2 molecule will release and form the intermediate 4, right? Now, hydration of this intermediate 4 will occur. How? Water molecule is added to this molecule by binding with the positively charged carbon, right? Oxygen from the water molecule attached to this positively charged carbon make the covalent bond with this positively charged carbon by using its lone pair of electron, right? Now, if lone pair of electron of oxygen atom is used, that's why oxygen acquire the positive charge and it become unstable and try to regain its lone pair of electron. That's why it releases the 1 H plus, right? Oxygen have 2 hydrogen atom, H2. Out of them, 1 hydrogen is removed in the form of H plus and it gives the electron to the oxygen and form the neutral OH group and form the intermediate 6. Now this intermediate 6 undergoes the tautomerization and form the product amide, that is structure 7 is amide. Right? Now what is tautomerization? There is a migration of hydrogen, that is proton, and electron within the molecule. See in structure 6, OH group have the hydrogen H plus and nitrogen. There is a pi bond between carbon and nitrogen, right? So H plus from the oxygen migrated toward the nitrogen atom and pi electron between carbon and nitrogen migrated between carbon and oxygen. CO bond will form and NH group will form, and combinedly it is CONH amide group, right? So corresponding amide is produced. Now examples: generally dialkyl ketones and cyclic ketones react more rapidly than alkyl aryl ketones. Dialkyl ketones, that means CO ketone group is attached to the 2 alkyl group, and alkyl aryl ketones, that means CO ketone group is attached to the 1 alkyl and 1 aryl group, right? So dialkyl ketone react more rapidly than alkyl aryl ketones, right? Here one example of cyclic ketone is given, that is cyclohexanone undergoes Schmidt reaction in presence of azide or hydrozoic acid and acid catalyst and form the lactams, that is cyclic amide, right? Alcohols and olefins react with hydrozoic acid to give alkyl azide, that is ROH group alcohol molecule converted into alkyl azide, that is RN3, right? And again olefins, that means double bonded compound converted into also alkyl azide. Next reaction is Oppenauer oxidation. Start with introduction. It is named after Rupert Victor Oppenauer. Scientist Oppenauer was first discovered and reported this oxidation reaction. That's why it is known as the Oppenauer oxidation. Right? Now what is oxidation? Oxidation involves the addition of oxygen atom or removal of the hydrogen atom from the substrate. Right? Now Oppenauer oxidation is a gentle method for selectively oxidizing secondary alcohol to ketone. That means Oppenauer oxidation involves the conversion of secondary alcohol to the ketone functional group. Right? This reaction is opposite to Meerwein-Wondorf-Verley reduction. Meerwein-Wondorf-Verley reduction involves the conversion of ketone to the secondary alcohol. It reduces the ketone to the secondary alcohol. That's why this reaction is just opposite to that reaction. The alcohol is oxidized by using aluminium isopropoxide in presence of excess of acetone. So in short, Oppenauer oxidation is carried out in the presence of aluminium isopropoxide and excess of acetone. Right? This shifts the equilibrium toward the product side. The oxidation is highly selective and does not occur in case of amines and sulfides. Right? This reaction is highly selective for the secondary alcohol. Only secondary alcohol get oxidized by this reaction. Amines and sulfides cannot be oxidized by Oppenauer oxidation reaction. Right? Also, primary alcohol do not undergo Oppenauer oxidation as they show competition with aldol condensation of aldehyde molecules. Right? Now, general reaction. Say in reaction R1CHOH R2, that is example of secondary alcohol. Right? This secondary alcohol react with excess of acetone, that is CH3COCH3, in presence of aluminium isopropoxide and heat. Right? It will form the R1COR2, that is corresponding ketone, and 2-propanol. Now see reaction mechanism. In first step, aluminium isopropoxide bind with the OH group of alcohol, secondary alcohol, and form the intermediate group. During this, what happens? When aluminium attached to the oxygen, one isopropoxide group will release from it. In aluminium isopropoxide, aluminium is attached to 3 isopropoxide group, right? So when aluminium attached to the oxygen atom, then one isopropoxide group is released from it, right, and form the intermediate group. Now in next step, what happen? Oxygen have the positive charge because of aluminium bind with oxygen through lone pair of electron of oxygen. That's why oxygen require the positive charge, because its lone pair of electron is used by for formation of bond between aluminium and oxygen. Right? Now in next step, what happen? Deprotonation will occur. How? Released isopropoxide group abstract the hydrogen in the form of proton from the oxygen. That's why OH bond will break and electron of this bond remain on oxygen, right? And that's why oxygen becomes neutral. It removes the positive charge, and hydrogen removed in the form of H+, that is abstracted by the isopropoxide group and form the 2-propanol, right? So structure 3 will obtain, right? Now in next step, this aluminium isopropoxide complex react with acetone, right, and form the intermediate 5. In this, aluminium bind to with the oxygen of the acetone, right? Oxygen of the acetone have lone pair of electrons, so that's why aluminium form the electrostatic bond with this oxygen atom by using its lone pair of electron, right? And simultaneously, hydrogen of this ketone molecule or precursor carbon have the hydrogen atom that bind with the carbon of the acetone and form the cyclic intermediate, that is 5th structure, right? Now rearrangement will occur and form the intermediate 6, right, that is hexagonal intermediate, and this intermediate undergoes the rearrangement and hydration will lead to the formation of the ketone molecule, right? Now application. The Oppenauer oxidation is used to prepare analgesic in the pharmaceutical industry such as morphine and codeine, right? For instance, codeine is prepared by Oppenauer oxidation of codeine. See in reaction, codeine undergoes the this Oppenauer oxidation and form the codeine. Here see secondary alcohol group at the second position undergoes the oxidation and form the ketone groups. CHOH group is converted into C double bond O, that is ketone group, and form the codeine. This oxidation is also used to synthesize hormones, for example progesterone, right? Progesterone is prepared by the Oppenauer oxidation of pregnenolone. Pregnenolone undergoes the Oppenauer oxidation and form the progesterone. It is also used in synthesis of lactones from 1,4 and 1,5 diols. Here one example of steroid that have the 1,4 and 1,5 diol is given, and this steroid undergoes the Oppenauer oxidation and form the corresponding lactone, right? So that's why it is majorly useful for the synthesis of natural products. Okay? Thank you.